Hello guys, welcome to Bugs in Code, and the problem that we are going to solve today is Apple sequences. So this problem is present at Geeks for Geeks, and I'm even going to provide the link in the description box. But before that, if you're new here and a person who likes stuff related to coding, then you can subscribe my channel, that is Bugs in Code. So let's get started. The problem statement says that there is a string of size n containing only A and O character. A stands for apple and O stands for oranges. We have m number of spells. Okay, each spell allows us to convert an orange into an apple. Okay, find the longest sequence of apples that you can make given n string and value of m. Okay, so here we are also given one example. So let me explain the example. The example says that we have the value of n as 5 and we have m equals to 1, and we have an array that gives us the sequence of apple and oranges. Okay, so the array have a a o a and o. So here if you notice then that we have choice to make any one orange to apple. So what we are going to do is we are going to traverse here, and then if we make this orange as apple, then we have this much sequence of containing just apple. So if it becomes apple, then it is going to be a a and a. So we can have one of the possible sequence of size 4. After that, if we make this as an apple, so we will have this we will have this sequence. So this sequence is going to be a and a. This is of size 2. Out of this, the maximum number of apples sequence that we can have is of size 4. So 4 is going to be my output. So this is my answer. Okay, so let me take one more example. So it has the size 9 and value of m as 2, and we are given an array as a a o o a o a a and a. Let me count the size: 1 2 3 4 5 6 7 8 and 9. Okay, so what we can do here, one option that we have is we can make we have the maximum number of 2 spells, so that we can make 2 oranges to apple. So if we make these 2 oranges to apple, then we will have this sequence containing just apple. So let me write it: a and a. So the size of this sequence is going to be 5. Also, if we make these 2 oranges as apple, so we will have this size, and it will be 1 2 3 4 5 and 6. So we will have a. So this is going to be of size 6. Okay, so out of these, this is greater, so 6 is going to be my output. So this is all about the problem. I hope you got the clear understanding what the problem is actually saying, and let me just move to the solution. Let me write solution here. Okay, so what we can do, let me write the previous example again. So n is equal to 9, m is equal to 2, and we have an array which was a a o o a o a a and a. Okay, so this is our array. What we can do, we can actually keep track of how many oranges we have got so far. Like, for this it is not an orange, for this it is not an orange, for this it's an orange, so I got one orange. And since I have one orange, so I can count this because I can make this orange as m. So whenever I get an orange, then I can do something like subtracting the value of this m, or just checking, comparing with this m. It's okay. So when we come here, then we have two oranges, and these two oranges are still equal to 2, then we can even count them. Now we have a. So if you talk about the answer, so initially our answer was 1 2, so count becomes equal to 1, so answer become 3. After that, here answer becomes 4, and here answer becomes 5. Here my count becomes 3. Now 3 is something where we have to think, because 3 is greater than 2. So now what we are going to do is we are going to move a pointer that was at here to uh, right direction. Like here we have a, here we have a, here we have o. So we can subtract this much of size. I mean, we can exclude this much of size from our total array that we have got so far. Like we have traversed this much of array in my answer, but we have to exclude this one in order to count these two o. So now what we have is we have something like a window of this size. Focus what I'm saying. I have a window of this size, so it's kind of sliding window that I'm sliding, so, but it has a variable size. So this problem is can be categorized as a problem of sliding window of variable size. Okay, so let me move ahead again. Here we have two o's, so what we can do is we can just count them, and now my answer has become. Now I'm not going to continue this because we have changed our window size. So now I have 3 as my count, this 3, and after that when we move here, then this 3 becomes this 4. After that when we move here, so it becomes 5, and after that when we move here, it becomes 6. So now we have maximum 6 elements that I have converted after forming this conversion. So this array this array is going to be my answer, which I have highlighted. I hope you got the clear understanding of the approach. So what we are going to do is, let me just explain this once more. So what we can have is we have an array a. Okay, so we will have a pointer at this place. I will call it pointer I, and we will have this moving pointer at this place. I call it j. So if we have, and I will have a count o variable which is initially equal to 0. Okay, so when we are at this, so we have a, so we can count a to answer, and our answer has become 1. Okay, now what we can do is we can have increment j. So now the count of a becomes 2, and we have no any 0, so our answer has increased to 2. After that my j increases, and now we have count as 1, but we have the value of m as 2, so we are okay with one count, so we can just going to move further, and we are even going to increase our answer because we can change this o to a. Okay, so now we have one more o. I'm not right, we have one more o, and what we are going to do is we are again going to increase my counter, and after that we are going to increase the answer. After that we are going to go to this element, and now it is a, so we are okay with this a, and we can just write 5. Okay, this time our counter has become 3. Now what we are going to do is we are going to increase this I in order to increase this value of the counter, so that we get value of 2 or lesser than 2. So our count o should be lesser than or equal to m. It is very important information. Now we are going to increase our I. So when we increase our I to here, then still we have 3 count because we have not visited any o yet. So now we are at here, and we have decreased our counter to 2, and we are just going to increase the element. So now you can see that we have this window, and this window has only 2o, so we can replace this 2o easily, and we are at this position. So at this position we have j minus I plus 1, that is, so j minus I plus 1 is basically done to calculate the window size. It is going to come as 3, like 0 1 2 3 4. This is fifth index, so it is fifth index, and 0 1 2 3, this is third index. So 5 minus 3 plus 1 is nothing but 3. Okay, now 3 is something that is not greater than 5, so our answer is not going to change. After that I'm going to increase my j value here. Okay, so now our window size become j minus I plus 1, that is going to be 4. So 4 is still not greater than 5, then we're just going to move our pointer to this. After that we have size as j minus I plus 1, which is equal to nothing but 5. 5 is still not greater than 5, it is equal to 5, and we are okay. So now we are going to increase our pointer j, and you can see here we have a, so we are not going to, okay, so here we have window size of j minus I plus 1, which is equal to 6, and 6 is something that is greater than 5, so we are just going to increment 6 to 5 to 6. Now we have traversed the whole array, and what we got is 6 as our maximum window size. So this is what we are going to return. I hope you got what actually I am trying to explain in this approach. So it's kind of sliding window of variable size. So this is all about the approach, and let me just code it out. You can see this is the problem at Geeks for Geeks, and let me just code the problem. So we are going to have a variable that is answer, which is going to initialize as 0. Like we can have 0 as my answer minimum. After that what we are going to, and we have to maximize this value. After that we are going to have a starting index that is 0, and we are just going to traverse the whole array with my j index. Okay, so here we need even one more variable that is going to be our count o, so that we can count the oranges. I hope you're understanding. So now whenever my current character is equal to O, then I'm going to increase my counter O. After that, I'm going to exclude all the elements from the front side, so that our count become less than or equal to j. So what I'm going to do is, while my I is smaller than j and my count is smaller than greater than m, then I'm just going to, if my caret I is double equal to O, then we are going to decrease our counter. Else we are also we are going to increase our value of 5. Now after that we are going to calculate the window size and maximize, then I'm going to do both these steps in just one expression. So our answer will maximum answer, and our window size, that is g minus I plus 1. So this is the approach, and let me just check for the compilation error. I don't think it should give me any compilation error, and this is all about the approach. Let me just run this. Okay, triple equals here. Let's check whether it's working or not. It's saying null pointer exception at line number 19, line number 18, but why? Okay, so this is because there's some random test case that is running. Now I have passed the sample test case, and let's check whether it's working or not. Okay, so it's giving me correct output, and just let me submit this. So it should work. Let's see. Okay, so it's working, and this is the approach that is going to solve this problem, and I hope you understand the problem. And if you like the video, then you can uh, hit the like button and even subscribe my channel so that you will never miss out an update. So this is all about the video. Thank you.